Question 1. Which inequality gives a domain of y equals the square root of 2x minus 3? Now what's inside the square root must be greater than or equal to 0. That means 2x minus 3 must be greater than or equal to 0. So solving this inequality, so making x the subject of this inequality, we'll add 3 to both sides. So no need to switch the inequality sign. So we have 2x is greater than or equal to 3. And then dividing both sides of the inequality by 2, we have x is greater than or equal to 3 over 2. So therefore, answer is option D. Question 2. The function f of x equals x cubed is transformed to g of x equals x minus 2 all cubed plus 5 by a horizontal translation of 2 units followed by a vertical translation of 5 units. Which row of the table shows the directions of the translations? Consider the function y equals x cubed. Its graph is a cubic curve that passes through the origin. Next, we'll consider the vertical and the horizontal translations in isolation. Now y equals x cubed plus 5 has the effect of moving the curve upward by 5 units. And we can think of this plus 5 here as adding 5 to all the y coordinates on this curve. Y equals x minus 2 all cubed moves the curve to the right 2 units. And we can find that by solving the equation x minus 2 equals 0 and x equals 2. So that's a horizontal translation to the right of 2 units. And if we combine the two, of course, we get the curve moving upward by 5 and then to the right by 2. So the answer is option B. Question 3. John recently did a class test in each of 3 subjects. The class scores on each test were normally distributed. The table shows the subjects and John's scores as well as the mean and standard deviation of the class scores on each test. Relative to the rest of the class, which row of the table below shows John's strongest subject and his weakest subject? Since class scores were normally distributed, Z-scores can be used to determine John's relative performance in each subject. So John's Z-score for French is equal to John's raw score minus the mean for French divided by the standard deviation for French, and that equals positive 1. The Z-score for commerce is equal to 80 minus 65 divided by 5, and that equals positive 3. And the Z-score for music is equal to 74 minus 50 divided by 12, which is equal to positive 2. So John's strongest subject, relatively speaking, is commerce, and John's weakest subject was French. So the answer is option A. Question 4. What is the indefinite integral of e plus e to the power of 3x dx? Consider the integrand one term at a time. E is a non-zero constant, so the integral of e with respect to x is e multiplied by x plus c. To check that result, you can differentiate the right-hand side. So the derivative of plus c is just 0, so the c disappears. And the derivative of e multiplied by x with respect to x, the x disappears, and we're left with e. The integral of e to the power of 3x is just e to the power of 3x divided by 3 or multiplied by 1/3 plus some constant c. We can check that result by differentiating the right-hand side, and the derivative of 1/3 multiplied by e to the power of 3x plus c is just e to the power of 3x. So combining these two results, the integral of e plus e to the power of 3x with respect to x is ex plus 1/3 multiplied by e to the power of 3x plus some constant c. So therefore, the answer is option B. Question 5. Which of the following could represent the graph of y equals negative x squared plus bx plus 1, where b is greater than 0? Firstly, the coefficient of the leading term x squared is negative, so the parabola is concave down. That means the answer is either option C or D. Next, we need to determine whether the vertex of the parabola lies to the left-hand side or the right-hand side of the y-axis. And we can use the formula x equals negative b on 2a to help determine that. And in this case, x equals negative b over 2 times negative 1 being the coefficient of the leading term, and that equals b over 2. But b is greater than 0, So the vertex is to the right of the y-axis. So therefore the answer is option C. Question 6. Which interval gives the range of the function y equals 5 plus 2 cos 3x? Consider the function y equals cos 3x. The 3x compresses the curve horizontally by a factor of 3, but it has no effect on the range. The range of cos 3x is still from -1 to 1. So if it's set up as an inequality, if we multiply cos 3x by 2, that dilates the curve or amplifies the curve by a factor of 2. So instead of the range being from -1 to 1, the range will be from -2 to +2. So multiplying each of the terms of this inequality by 2, we can see what happens. We end up with the range being from -2 to +2 for the function 2 cos 3x. Next, we'll add 5 to this function. So that translates the curve upwards by 5 units. So adding 5 to each of the terms of this inequality, we get -2 plus 5, which equals 3. 2 cos 3x plus 5 is just 5 plus 2 cos 3x, which is the function in the question. And 2 plus 5 is equal to 7. So the range is between 3 and 7, including the endpoints. So the answer is option B. Question 7. The diagram shows the graph of y equals function x, which is made up of line segments and a semicircle. What is the value of the integral from 0 to 12 of f of x dx? The question is asking for the value of a definite integral, not the area bounded between the curve and the x-axis. So that means we need to take into account whether the areas are positive or negative. So in this instance, this area here and this area here will cancel since the two areas are identical but opposite in sign. So this positive area here will cancel with this negative area here. So there's only two regions we need to consider. This region here, A1, and that's just a rectangle, and then region A2, which is a semicircle. So region A1 is just 8 times 3, which is 24, and region A2, area of a semicircle, is half pi r squared, so that's equal to half times pi times 2 squared, and that's why I just wrote the 6 there, just to make it clear that the radius here is 2 units, and that's equal to 2 pi. So the answer is option A, 24 plus 2 pi. The graph of y equals function x is shown. Which of the following inequalities is correct? Assuming the graph is drawn to scale, the y-coordinate of this point is around 1.3. So the horizontal distance is 1 centimeter, and the vertical distance, so the distance from the x-axis to the point, is around 1.3. So f of 1 is approximately 1.3. Now the value of the gradient of the tangent to the curve at this point is approximately 1. So that was just done by inspection. And the value of the second derivative at this point I found by analyzing the gradient of the tangent at some point to the left of 1, of the point where x equals 1, and some point to the right of x equals 1. And I found that the gradient of the tangent decreased as we went from left to right. So that means the second derivative at this point must be negative. Therefore, the second derivative at x equals 1 is less than 0, which is less than the first derivative at x equals 1, which is less than the value of the function at x equals 1. So therefore, the answer is option A. Question 9. Suppose the weight of melons is normally distributed with a mean of mu and a standard deviation of sigma. A melon has a weight below the lower quartile of the distribution, but not in the bottom 10% of the distribution. Which of the following most accurately represents the region in which the weight of this melon lies? Referring to the empirical rule, mu minus sigma corresponds to a z-score of -1, which corresponds to the lower 16% of the normal distribution. But we're told that the melon weight lies somewhere in the bottom 25% or the lower quartile. Hence, the melon weight has a maximum z-score somewhere between -1 and 0. Now mu minus 2 sigma corresponds to a z-score of -2, which corresponds to the lower 2.5% of the normal distribution. But we're told that the melon weight is not in the bottom 10% of the distribution. Hence, the melon weight has a minimum z-score somewhere between -2 and -1. Therefore, the answer is option C. Question 10. The graph shows two functions, y equals f of x and y equals g of x. Define h of x equals f of g of x. How many stationary points does y equal h of x have for x greater than or equal to 1 and less than or equal to 5? H of x equals f of g of x, which is a composite function. And to differentiate composite functions, the chain rule needs to be applied. H dash of x is equal to the derivative of f of g of x, which is equal to the derivative of the outer function, which is f dash of g of x, multiplied by the derivative of the inner function, which is g dash of x. Now to find the stationary points, we let h dash of x equal 0. And that occurs when either f dash of g of x equals 0, so that term of the product, or g dash of x equals 0, this term of the product. So either one of those two has to equal 0. So we'll consider both cases, case 1 and case 2. Consider case 1, where f dash of g of x equals 0. If we go back to the original graph, let's have a look at y equals f of x. And we can see that there's a stationary point that occurs when x equals 1. In other words, f dash of 1 equals 0. So going back to case 1, f dash of 1 equals 0 implies that g of x must equal 1. After all, it's f dash of g of x equals 0, and g of x must equal 1, since that's where the stationary point occurs. Now, where does g of x equal 1? And that occurs twice in the domain x between 1 and 5. So if I go back to the original graph, I've marked that in. So g of x equals 1 here and here. And it's f dash of 1 is where the stationary point occurs on the curve y equals f of x. So two stationary points occur there. Now let's look at case number 2, g dash of x equals 0. And that one's straightforward. And that occurs at x equals 3. So if we go back to the graph, y equals g of x, so g dash of x equals 0 at this point at the vertex of the parabola. So that's where the third stationary point occurs. Hence, h of x has 3 stationary points, and therefore the answer is option D. Question 11. There are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres of water and tank B is empty. Part A. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in tank A is modelled by V equals 1,000 minus 20T, where V is the volume in litres and T is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. V equals 1000 minus 20t is a linear model, and its graph will be a straight line. To draw a straight line, we need a minimum of 2 points to locate it. So it was easy enough to find the y-intercept and the x-intercept by letting t equals 0 to find the y-intercept and v equals 1000, and to find the x-intercept, I let t equal 50 and v equals 0. And so just joining the 2 points there, we have the line that represents the graph for tank A. Part B. Tank B remains empty until t equals 15 when water is added to it at a constant rate of 30 litres per minute. By drawing a line on the grid on the previous page, or otherwise, find the value of t when the 2 tanks contain the same volume of water. An algebraic approach will be used to answer part B. First, we need to determine the equation that models the amount of water in tank B, and it's a linear model as well. We know that the gradient is 30, since that comes from the question, water is being added at a constant rate of 30 litres per minute, and we know that at time equals 15 minutes, at that instant, there's no water in tank B, and it's from that point onwards that water is being added at the rate of 30 litres per minute. So we need to determine what the y-intercept will be. So the model is y equals 30t plus c, and we need to determine the plus c. And we know that at time t equals 15, at that instant, there's no water in tank B. So 0 equals 30 multiplied by 15 plus C. 30 multiplied by 15 is 450. Therefore, C, the y-intercept, is negative 450. Therefore, the equation that models tank B is y equals 30t minus 450. Now we solve the equations y equals v simultaneously. So we want to find out at what time the two tanks will have an equal amount of water. So y is equal to 30t minus 450, and we equate that with the equation for v, which is 1000 minus 20t. So that's the amount of water in tank A at some point in time t. And collecting like terms and solving for t, we have 50t is equal to 1450, and dividing both sides by 50, we have t equals 29. So therefore, the tanks will contain the same volume of water right after the 29-minute mark. Part C. Using the graphs drawn or otherwise, find the value of t, where t is greater than 0, when the total volume of water in the two tanks is 1000 litres. Since we've already determined the equation that models the amount of water in tank B, we can use an algebraic approach for part C. We're going to solve the equation y plus v equals 1000 for t, where y represents the amount of water in tank B and v represents the amount of water in tank A at some point in time t. Now y is equal to 30t minus 450 and v is equal to 1000 minus 20t. So combining the like terms and just rearranging the equation, we have 10t is equal to 450, dividing both sides by 10, we have t equals 45. Question 12. Calculate the sum of the arithmetic series 4 plus 10 plus 16 plus ... plus 1354. The first term of this arithmetic series is 4 and the common difference is 6. And we can get that by taking a term and subtracting the term before it. So 10 minus 4 is 6, or 16 minus 10 is 6. We need to determine the n though. That's the number of terms that are in the series. N also corresponds to the position of the last term. So 1354, we need to determine what position in the series this term is here. Then we can apply the formula, sum to n terms is equal to the average of the first and last terms multiplied by the number of terms in the series. So we can solve the equation. 1354 is equal to a plus n minus 1d. So a is 4, d is 6. We need to solve for n. So subtracting 4 from both sides, we have 1350 is equal to n minus 1 multiplied by 6. We get 225 is equal to n minus 1, so dividing both sides by 6. And then adding 1 to both sides, we get n equals 226. So this term here, 1354, is the 226th term in the series. Now we can apply the formula for the sum of n terms of this series. So S226 is equal to the average of the first and last terms multiplied by the number of terms in the series. And the last term is 1354. So substituting in these values, S226 is equal to 4 plus 1354 over 2. So the average of the first and last terms, multiply that by 226, and that equals 153,454. Question 13. Evaluate the integral from 0 to pi on 4 of sec squared x dx. Recall that the derivative of tan x equals sec squared x. Hence, the integral of sec squared x equals tan x. Now, the definite integral from 0 to pi on 4 of sec squared x dx is equal to tan x from 0 to pi on 4. So, applying the limits of the integral, that equals tan of pi on 4 minus tan of 0. And tan of pi on 4, of course, is 1. Tan of 0 is 0. 1 minus 0 is equal to 1. Question 14. History and geography are two of the subjects students may decide to study. For a group of 40 students, the following is known. 7 students study neither history nor geography. 20 students study history. 18 students study geography. Part A. A student is chosen at random. By using a Venn diagram or otherwise, find the probability that the student studies both history and geography. Here is a Venn diagram that represents the situation. So we have our two circles, one for geography, one for history. So we need to populate this Venn diagram. So firstly, 7 students study neither history nor geography. So 7 can go outside the two circles. Next, we need to determine the value of the intersection. So the number of students that study both geography and history. So if 7 students study neither, that leaves 33 students that study one or the other or both. Now, we're given that 20 students study history and 18 study geography. So 20 plus 18 is 38, but there's 33 students physically. So that means that there has to be some students that study both. And so to work that out, the number of students that study geography and history is equal to 18 plus 20 minus 33, and that equals 5. So 5 goes in the intersection here. Now we can fill out the remaining two values. So the students that study geography exclusively, we have 18 students that study geography. We have 5 already accounted for. So in the geography circle, that needs to add up to 18. So that would make this value here 13, obviously. And same thing for history. We have 20 students that study history. 5 have already been accounted for. So that leaves 15 remaining that study history exclusively. So that's the Venn diagram filled out. So the probability that a student studies history and geography, so a student that's chosen randomly out of the 40, is equal to the number of students that study both geography and history divided by the total number of students. So these vertical lines here just mean the number of. And that equals 5 divided by 40, which is equal to 1 over 8. Part B. A student is chosen at random. Given that the student studies geography, what is the probability that the student does not study history? This is conditional probability. We're told here that given that the student studies geography, what is the probability that the student does not study history? So referring to the Venn diagram, go to the geography circle, we have 18 students that study geography, of which 13 do not study history. So they study geography only. So therefore, the probability is 13 over 18. Part C. 2 different students are chosen at random, one after the other. What is the probability that the first student studies history and the second student does not study history? This is an example of multi-stage probability where the outcome of the second stage is affected by the outcome of the first stage. And that's because it's sampling without replacement. So the probability that the first student chosen studies history is 20 over 40. There are 20 students that study history out of a total of 40 students. So that gives us a probability of 20 over 40. Now to find the outcome of the second stage. And the second stage is to find the probability that the second student chosen does not study history. So if 20 students out of the 40 study history, that means there's 20 students that do not study history. But because it's sampling without replacement, instead of being out of 40, we've already chosen one student from a previous stage, or from the first stage. The second stage only has 39 students. So the probability that the second student does not study history is 20 over 39. So to find the probability that the first student chosen studies history and the second student chosen does not study history, we multiply these two probabilities together, and that equals 10 over 39. Question 15. Mr. Ali, Miss Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 35 degrees for 7 kilometers to location A. Miss Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometers to location B. Part A. Show that the angle APB is 65 degrees. The size of angle APB is the difference between the two bearings in the question. Mr. Ali's group is walking on a bearing of 35 degrees, Miss Brown's group is walking on a bearing of 100 degrees, and the difference between the two, so 100 minus 35, is equal to 65. So therefore, angle APB is equal to 65 degrees. Part B. Find the distance AB. In triangle APB, the sides PA and PB are known, as well as the included angle, 65 degrees, which was found in part A. Because there are two known sides and an included angle, the cosine rule can be applied to find the length of the remaining side, AB. So by the cosine rule, a squared equals b squared plus c squared minus 2bc times cos A. A represents the angle here, 65 degrees. This lowercase a represents length or side AB. And B and C represent 7 and 9 kilometers, and it doesn't matter in which order. So AB squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 times cos 65 degrees. And if we raise the right-hand side to the power of half, that's the equivalent of taking the square root, because we don't want AB squared, we just want AB. So it's like taking the square root of the hypotenuse. And that equals 8.76 kilometers, correct to 2 decimal places. Part C. Find the bearing of Miss Brown's group from Mr. Ali's group. Give your answer correct to the nearest degree. In order to find the bearing of Miss Brown's group from Mr. Ali's group, another angle in triangle APB needs to be determined. Now there are 3 known sides and a known angle already. That means there's one known side angle pair, which means the sine rule can be applied to find another angle in triangle APB. I'm going to find angle PAB using the sine rule. So sine of angle PAB over 9 is equal to sine of 65 over 8.76. So that's the known side angle pair. So multiplying both sides by 9, we have sine of angle PAB is equal to 9 sine 65 degrees divided by 8.76. And taking the inverse sine of both sides, so shift sign on the calculator, angle PAB is equal to the inverse sine of 9 sine 65 degrees divided by 8.76, and that equals 69 degrees to the nearest degree. So the bearing of B from A is equal to 360 degrees minus 145 degrees minus 69 degrees, which equals 146 degrees. We'll have a quick look at the diagram just to see how those sides and angles are placed. So there's angle PAB. Now this angle here, so this 145 degrees, that comes from co-interior angles, since this north-south axis and this north-south axis are parallel. So these two angles are supplementary. So you have 145 degrees, we have 69 degrees, and it's this angle here that is the bearing of Miss Brown's group from Mr. Ali's group. So angles at a point add up to 360 degrees. So 360 minus 145 minus 69 degrees is equal to 146 degrees. Question 16. Sketch the graph of the curve y equals negative x cubed plus 3x squared minus 1, labeling the stationary points and the point of inflection. Do not determine the x-intercepts of the curve. The function is a polynomial with degree 3. The degree represents the highest power of the variable in the polynomial and defines the overall shape of the curve when graphed. So since the degree is 3, the shape is cubic. Now one point that this cubic curve is going to pass through is y-intercept of negative 1, and that can be found by letting x equal 0. Now let's consider the shape of the curve for large values of x and for small values of x. So as x approaches infinity, so x gets really large, y gets really small, y approaches negative infinity, and vice versa. As x approaches negative infinity, y will approach infinity. And that's because of the negative sign here, this is the leading coefficient, of the term that contains the degree. Now let's find the first derivative and the second derivative, because they will be required to find the stationary points, determining their nature, and also to find the inflection point and test it to make sure that it is in fact an inflection point. So y dash, the first derivative, is equal to negative 3x squared plus 6x. And equation number 2, this is the second derivative, so y double dash is equal to negative 6x plus 6. And we find that by differentiating the first derivative. Now to find the stationary points by solving, y dash equals 0, so just by making the first derivative here equal to 0 and solving for x. So we have negative 3x squared plus 6x equals 0, and dividing both sides by negative 3, we have x squared minus 2x equals 0. Factorizing out x, we have x outside of x minus 2 equals 0, and therefore x equals 0 or 2. Now at x equals 0, y is equal to negative 1, so we substitute 0 into the original polynomial there, original function, y equals -1, which also happens to be the y-intercept. And the second derivative is equal to 6, so that's to determine the nature of this stationary point. And because the second derivative is positive, this stationary point, 0, -1, will be a minimum. And at x equals 2, the y-coordinate of this point will be 3. So substituting 2 into the original function, we have y equals 3. And the second derivative at that point, so using equation number 2 here, that's equal to -6. And because the second derivative is negative, this point, this stationary point, will be a maximum. So we're going to have two stationary points, 0, -1, which is the minimum point, and 2, 3, which is a maximum point. Now to find the point of inflection. And that can be found by solving the second derivative equal to 0. So that's -6x plus 6 equals 0, so therefore x equals 1. But we need to test to make sure that it is in fact an inflection point. It's a possible point of inflection at this point. So at x equals 1, y equals 1, so that's the y-coordinate, so that's the actual coordinate of the inflection or the possible inflection point. So let's test if 1, 1 is in fact an inflection point by checking the sign of the second derivative around x equals 1. So we just dodge around it, just with it, not sort of large values of x, but just slightly to the left or to the right of x equals 1 is sufficient. So at x equals 0.9, the second derivative, y double dash, is equal to positive 0.6. And at x equals 1.1, the second derivative is equal to negative 0.6. So there is a sign change of the second derivative around the possible inflection point. Hence, the coordinate 1, 1 is an inflection point. Now we have enough information to graph the function. So here's the y-intercept, which happens to be the minimum stationary point. Here's the point 2, 3, which is the maximum stationary point. Here's the point of inflection there. Okay. Of course, just make sure use the ruler, draw the axes neatly, label the axes. So x, y, of course, the origin. And I tried to draw it somewhat to scale. It's not going to be 100% accurate, of course, but as long as the question is answered, it asked for labeling the stationary points and the point of inflection, and that's it. Question 17. Find the indefinite integral of x over 4 plus x squared dx. The expression to be integrated is a fraction where the numerator and the denominator involve functions of x. Now, if the numerator is equal to the first derivative with respect to x of the denominator, then the integral is the natural logarithm of the denominator. So ln of 4 plus x squared in this case. Now recall that the first derivative with respect to x of ln of f of x is equal to f dash of x over f of x using the chain rule. The first derivative of 4 plus x squared with respect to x is 2x. So we'd like a 2x to appear in the numerator. However, we just have x there, so it's half of what we want. So we're going to multiply the numerator by 2. So we have the first derivative of the denominator appearing in the numerator, but we need to compensate by this multiplication by 2 by multiplying the entire integral by half. Now integrating 2x over 4 plus x squared with respect to x is equal to ln of 4 plus x squared plus c. However, the entire integral is being multiplied by half, so the integral in our answer also needs to be multiplied by half as well. So that half is carried over. So the final answer is half multiplied by ln of 4 plus x squared plus c. Question 18, part A. Differentiate with respect to x, e to the power of 2x multiplied by 2x plus 1 in brackets. The expression to be differentiated is a product of two functions involving the variable. Part B. Hence, find the indefinite integral of x plus 1 in brackets multiplied by e to the power of 2x dx. The word hence means we need to use the result of part A to answer part B. So if we go back to part A, The derivative of e to the power of 2x multiplied by 2x plus 1 with respect to x is 4e to the power of 2x multiplied by x plus 1. Reversing that, the integral of 4e to the power of 2x multiplied by x plus 1 is e to the power of 2x multiplied by 2x plus 1. So if I have a look at the integrand in part B, it's x plus 1 multiplied by e to the power of 2x, which looks like the answer to part A. In fact, it's a quarter of the size. If there was a 4 here, if it was multiplied by 4, then the integral is straightforward. So if we multiply the integrand by 4, so we'll make it 4e to the power of 2x multiplied by x plus 1. We compensate for this multiplication by 4 by multiplying the entire integral by 1/4. So inside the integral there's a multiplication by 4, compensate by multiplying by 1/4 outside the integral. And the integral of 4e to the power of 2x outside of x plus 1 dx is just e to the power of 2x multiplied by 2x plus 1 plus c, but because of this 1/4, we need to multiply our answer by 1/4. So the integral of x plus 1 multiplied by e to the power of 2x dx is equal to 1/4 multiplied by e to the power of 2x multiplied by 2x plus 1 in brackets plus c. Question 19. Prove that sec theta minus cos theta equals sine theta multiplied by tan theta. Starting with the left-hand side and expressing sec theta in terms of cos theta, we have left-hand side equals 1 over cos theta minus cos theta over 1. To combine the two fractions, we need a common denominator. So if the denominator of the first fraction is cos theta, we would like cos theta to appear as the denominator of the second fraction. So we can multiply cos theta over 1 by cos theta over cos theta. Of course, that's equal to 1. And that equals 1 over cos theta minus cos squared theta over cos theta. Because we have common denominators, the numerators can be combined, so that equals 1 minus cos squared theta over cos theta. And taking note here that 1 minus cos squared theta is equal to sine squared theta. So that's one of the Pythagorean identities. So 1 minus cos squared theta can be expressed in terms of sine squared theta, so that equals sine squared theta over cos theta. Now sine squared theta is sine theta multiplied by sine theta. So that's equal to sine theta multiplied by sine theta over cos theta. And sine theta over cos theta is equal to tan theta. So that equals sine theta multiplied by tan theta, which equals sine theta tan theta, which equals the right hand side as required. Question 20. Kenzo is driving his car along a road while his friend records the velocity of the car, v of t, in kilometers per hour every minute over a 5-minute period. The table gives a velocity v of t at time t hours. The distance covered by the car over the 5-minute period is given by the integral from 0 to 5 over 60 of v of t dt. Use the trapezoidal rule and the velocity at each of the 6 time values to find the approximate distance in kilometers the car has travelled in the 5-minute period. Give your answer correct to 1 decimal place. Since there are 6 function values, 5 trapeziums will be used to estimate the area given by this integral, which represents the distance covered by the car over the 5-minute period. Recall that the area of a trapezium is given by the formula h over 2 multiplied by a plus b, where h represents the distance between the parallel sides of the trapezium. Now there are 5 trapeziums drawn adjacent to each other. So there'll be 4 common sides. 1, 2, 3, and 4. These sides here and here are not common, it will only be used once. Now the common height of each trapezium is 1 over 60, and that can be found by taking any 2 consecutive values of t and subtracting 1 from the other. Now the area is approximately equal to h over 2, so h is 1 divided by 60, and divide that by 2, outside of 60 plus 2 multiplied by 55, since that is one of the common sides, plus 2 multiplied by 65, plus 2 multiplied by 68, plus 2 multiplied by 70, plus 67. And that's approximately equal to 5.358, and rounded to 1 decimal place, that's approximately equal to 5.4 kilometers, correct to 1 decimal place. Question 21. Hot tea is poured into a cup. The temperature of the tea can be modelled by capital T equals 25 plus 70 multiplied by 1.5 to the power of negative 0.4 T, where capital T is the temperature of the tea in degrees Celsius, T minutes after it is poured. Part A. What is the temperature of the tea 4 minutes after it has been poured? Substitute T equals 4 into the formula for the temperature of the tea. So capital T equals 25 plus 70 multiplied by 1.5 to the power of negative 0.4 times 4. And evaluating that expression, that equals 61.589 ... degrees Celsius. And rounding that to one decimal place, that equals 61.6 degrees Celsius. Part B. At what rate is the tea cooling 4 minutes after it has been poured? Recall that the first derivative with respect to x of a to the power of f of x equals ln a multiplied by a to the power of x multiplied by f dash of x. Hence, d capital T dt equals 70 multiplied by ln 1.5 multiplied by 1.5 to the power of negative 0.4 t multiplied by negative 0.4. When t equals 4, d capital T dt is equal to 70 multiplied by ln 1.5 multiplied by 1.5 to the power of negative 0.4 times 4 multiplied by negative 0.4. And that evaluates to negative 5.9342 ... degrees Celsius per minute. And rounding that to one decimal place, that equals negative 5.9 degrees Celsius per minute. Therefore, the tea is cooling at a rate of 5.9 degrees Celsius per minute after 4 minutes. Part C. How long after the tea is poured will it take for its temperature to reach 55 degrees Celsius? Let capital T equal 55 and then solve for t the equation 55 equals 25 plus 70 multiplied by 1.5 to the power of negative 0.4 t. Subtract 25 from both sides and we get 30 equals 70 multiplied by 1.5 to the power of negative 0.4 t. Divide both sides by 70, we get 3 over 7 equals 1.5 to the power of negative 0.4 t. Next, take the natural logarithm of both sides. We have ln 3 over 7 is equal to ln 1.5 to the power of negative 0.4 t. Then we apply log law number 3, where the power, or the index, comes out to the front. So we get ln 3 over 7 is equal to negative 0.4 t multiplied by ln 1.5. Next, we divide by ln 1.5. So ln 3 over 7 divided by ln 1.5 equals negative 0.4 t. And then finally divide both sides by negative 0.4 t. So ln 3 over 7 divided by ln 1.5 divided by negative 0.4 equals t. So evaluating the left-hand side, we get t equals 5.2242 ... minutes, and rounding that to 2 decimal places, t equals 5.22 minutes. Question 22. The diagram shows a regular decagon, 10-sided shape with all sides equal and all interior angles equal. The decagon has center O. The perimeter of the shape is 80 centimeters. By considering triangle OAB, calculate the area of the 10-sided shape. Give your answer in square centimeters, correct to 1 decimal place. Considering triangle OAB, side AB equals 8 centimeters, and that's found by taking the perimeter of this decagon, 80 centimeters, and dividing it by 10, since there are 10 equal length sides that make up this shape. Angle AOB, so that's the angle at the center, is equal to 360 degrees divided by 10, which equals 36 degrees, and that's because angles at a point add up to 360 degrees, and there are 10 equal interior angles. Now let x equal OA equal OB, and because OA equals OB, triangle AOB is isosceles. And hence, angle OAB, so that's one of the base angles, is equal to 180 degrees minus 36 degrees in brackets divided by 2, which equals 72 degrees. And that's shown in this diagram here. Now to find the value of x, so that's either length OA or OB, the sine rule can be used since there are 3 known angles, 1 known side, so there's a known side angle pair. So by the sine rule, x over sine 72 degrees is equal to 8 over sine 36 degrees. And making x the subject of the formula, we have x equals 8 sine 72 degrees divided by sine 36 degrees. and I've left it in exact form. Now by the area rule for triangles, now that all the sides are known and the included angle is known, of course, so these two sides are known and we have an included angle, the area of triangle OAB is equal to half x squared multiplied by sine 36 degrees. So that comes from the formula half AB sine C. Now a decagon is made up of 10 of these triangles. So the area of the decagon is equal to 10 times the area of triangle OAB, which is equal to 10 multiplied by, now this is in square brackets here, half multiplied by 8 sine 72 degrees divided by sine 36 degrees squared multiplied by sine 36 degrees. So that's the half x squared multiplied by sine 36 degrees, and that equals 492.429 ... and that rounds to 492.4 square centimeters, correct to one decimal place. Question 23. A continuous random variable, x, has the following probability density function. f of x equals sine x for x greater than or equal to 0 and less than or equal to k, and f of x equals 0 for all other values of x. Part A. Find the value of k. A continuous probability density function behaves in a similar way to a discrete probability density function, and it's valid if and only if function x is greater than or equal to 0 and less than or equal to 1, and the integral from a to b of f of x dx equals 1. This is similar to a discrete probability density function where the probabilities of all the outcomes, that's p of x, must lie between 0 and 1, and the sum of all the probabilities must equal 1. Now the integral from 0 to k of sine x dx equals 1. We want to solve for k. And the integral of sine x with respect to x is negative cos of x, and the limits are from 0 to k, and that expression equals 1. Expanding the brackets and applying the limits, we have negative cos of k plus cos of 0 equals 1, and cos of 0 equals 1. So negative cos of k plus 1 equals 1, and subtracting 1 from both sides, we have negative cos of k equals 0, multiplying both sides by negative 1, we have cos of k equals 0, and therefore k equals pi on 2. Part B. Find the probability that x is less than or equal to 1. Give your answer correct to 4 decimal places. The probability of x less than or equal to 1 is given by the integral from 0 to 1 of sine x dx, and that equals negative cos of x from 0 to 1. Expanding the brackets and applying the limits, we have negative cos of 1 plus cos of 0 is equal to 0.459697, and so on. Rounding that value to 4 decimal places, that equals 0.4597. Now, as a side note, for both parts A and B, ensure your calculator is set to radians when working with calculus involving trigonometric functions. Question 24. The circle x squared minus 6x plus y squared plus 4y minus 3 equals 0 is reflected in the x-axis. Sketch the reflected circle, showing the coordinates of the center and the radius. Reflecting a circle in the x-axis changes the y-coordinate of its center while leaving its radius unchanged. To find the coordinates of the center and the radius of the original circle, we express the left-hand side as a sum of perfect squares. So starting with the x variable, completing the square on x squared minus 6x, we take the coefficient of x, which is negative 6, we halve it, which is negative 3, and then we square negative 3, which is positive 9. So we add that to x squared minus 6x. And we do the same thing to the y variable. So y squared plus 4y, we take the coefficient of y, which is 4, we halve it and then square it. So half of 4 is 2, and 2 squared is 4, and we add that to y squared plus 4y. So we end up with y squared plus 4y plus 4. Now the negative 3, we move that to the other side by adding 3. So negative 3 on the left becomes positive 3 on the right. And because we've added 9 and 4 to the left-hand side of the equation, to keep it balanced, we also need to add 9 and 4 to the right-hand side. So 3 plus 9 plus 4 is equal to 16. And expressing the left-hand side in factorized form, we have x minus 3 all squared plus y plus 2 all squared is equal to 16. So that's now in perfect square form. And from that, we can see that the radius of the circle is 4, and it's centered on 3, negative 2. Now to reflect the circle in the x-axis, we take the y-coordinate of the center of the original circle, which is -2, and multiply that by -1. And so the reflected circle has a radius of 4, and it's centered on 3, +2. And here's the graph of the reflected circle. So the center is clearly noted there. So 3, 2, and the radius is 4. And I used a pair of compasses to draw that, and I tried to keep it to some sort of scale as well. Question 25. A landscape gardener wants to build a garden bed in the shape of a rectangle attached to a quarter circle. Let x and y be the dimensions of the rectangle in meters as shown in the diagram. The garden bed is required to have an area of 36 square meters and to have a perimeter which is as small as possible. Let p meters be the perimeter of the garden bed. Part A. Show that p equals 2x plus 72 over x. The first consideration is the area of this composite shape. The area of the rectangle plus the area of the quarter circle is equal to 36 square meters. Now the area of the rectangle is equal to xy, or x multiplied by y, and the area of the quarter circle is pi r squared over 4, where r is equal to x meters, which is the radius of this quarter circle. Now rearranging this equation to make xy the subject, we have xy is equal to 36 minus pi x squared over 4. And dividing all terms by x, we get y is equal to 36 over x minus pi x over 4, and we'll call that equation number 1. Our next consideration is the perimeter of this composite shape. And the perimeter P is equal to 2y plus 2x plus pi x over 2. So there's y, there's another y, that's our 2y. We have an x here and an x there, so there's the 2x. And we have the curved side here, which is 1/4 the circumference of a full circle. So that's 2 pi r, or 2 pi x, divided by 4. Hence why the perimeter here of the quarter circle is pi x over 2. And we'll call that equation number 2. Now we're going to substitute equation number 1 into equation number 2 to eliminate the y variable. So from equation number 2, we have p equals 2. Now instead of the variable y, we're going to substitute 36 over x minus pi x over 4 plus 2x plus pi x over 2. And expanding the brackets, we have p is equal to 72 over x minus pi x over 2 plus 2x plus pi x over 2. And of course you get some cancellation there and there. And therefore pi is equal to 2x plus 72 over x as required. Part B. Find the smallest possible perimeter of the garden bed, showing why this is the minimum perimeter. Since the perimeter P can be expressed in terms of x, we can use the first derivative to find the value of x that gives the minimum perimeter. But first we need the first derivative dp dx, or p dash. And p dash is equal to 2 minus 72 over x squared. Next we solve for x, the equation p dash equals 0, to find any stationary points. So that's 2 minus 72 over x squared equals 0. And multiplying all the terms by x squared, we get 2x squared minus 72 equals 0. Dividing all terms by 2, we get x squared minus 36 equals 0, or x squared equals 36. And of course, the two solutions there are x equals -6 or +6. But x needs to be positive since it is a length, it's the width of the rectangle. So therefore, x equals 6 is the only valid solution. But we need to check that x equals 6 gives the minimum perimeter. And we can do that by checking the sign of p dash around x equals 6. And I've summarized those results in a table of values. So at x equals 6, p dash is equal to 0, so that's the stationary point. At x equals 5, so to the left of x equals 6, p dash is equal to -22 over 25. So all you need to do is just substitute x equals 5 into the equation for the first derivative. And that's a negative gradient there. And at x equals 7, p dash is equal to 26 over 49. And we can see that that's a positive gradient to the right-hand side of x equals 6. So x equals 6 represents the value that gives the minimum perimeter. Now to find the minimum perimeter, we substitute x equals 6 into the equation for perimeter. So perimeter equals 2x plus 72 over x, and substituting x equals 6 into that equation, we get P equals 2 multiplied by 6 plus 72 over 6, which equals 24 meters, and therefore the minimum perimeter for the garden bed to have an area of 36 square meters is 24 meters. Question 26. Tina inherits $60,000 and invested in an account earning interest at a rate of 0.5% per month. Each month, immediately after the interest has been paid, Tina withdraws $800. The amount in the account immediately after the nth withdrawal can be determined using the recurrence relation AN equals AN minus 1 multiplied by 1.005 minus 800, where n equals 1, 2, 3, and so on, and A0 equals 60,000. Part A. Use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. Using the recurrence relation, the amount of money in the account immediately after the first withdrawal is given by A1 equals A0 multiplied by 1.005 minus 800, and A0 is equal to 60,000. So A1 equals 60,000 multiplied by 1.005 minus 800, which equals 59,500. Now A2, which is the amount of money in the account immediately after the second withdrawal, is given by 59,500, so that's A1, multiplied by 1.005 minus 800, and that equals $58,997.50. And A3, so the amount of money in the account immediately after the third withdrawal, is given by $58,997.50, so that's A2, multiplied by 1.005 minus 800, and that equals 58,492.4875, and rounding that amount to 2 decimal places, that equals $58,492.49. So therefore, the amount of money after the third withdrawal is equal to $58,492.49. Part B. Calculate the amount of interest earned in the first 3 months. Assuming no interest is paid, the amount of money in the account immediately after the third withdrawal is given by 60,000 minus 3 multiplied by 800, which equals $57,600. But interest was paid. And the amount of money that Tina has in her account after the third withdrawal is in fact equal to $58,492.49. So the difference between this value and $57,600, which is the amount of money in the account assuming no interest was paid, is given by $58,492.49 minus $57,600, and that equals $892.49. So that was the amount of interest Tina earned in those 3 months. Part C. Calculate the amount of money in the account immediately after the 94th withdrawal. The solution to this problem involves the sum to n terms of a geometric progression. Using the recurrence relation, A1 is equal to A0 multiplied by 1.005 minus 800. Now A2 is equal to A1 multiplied by 1.005 minus 800. But expressing A2 in terms of A0, by replacing A1 by A0 multiplied by 1.005 minus 800, we get A2 is equal to A0 multiplied by 1.005 minus 800. So this expression in brackets is equivalent to A1. And that's multiplied by 1.005, and then we subtract 800. Then expanding the brackets, we get A2 is equal to A0 multiplied by 1.005 squared minus 1.005 multiplied by 800 minus 800. So the geometric progression is forming here. Let's consider A3. Now A3 is equal to A2 multiplied by 1.005 minus 800. But A2 is this expression here. So A3 can be expressed in terms of A0 by taking this expression and substituting it for A2 here. So we have A3 is equal to A0 multiplied by 1.005 squared minus 1.005 multiplied by 800 minus 800, all in brackets, multiplied by 1.005 minus 800. And expanding the brackets, so by multiplying all the terms inside the bracket by 1.005, we get A3 is equal to A0 multiplied by 1.005 cubed minus 800 multiplied by 1.005 squared minus 800 multiplied by 1.005 minus 800. So we can clearly see a geometric progression here. And factorizing negative 800 out of these terms here, we get A3 is equal to A0 multiplied by 1.005 cubed minus 800 outside of 1 plus 1.005 plus 1.005 squared. So that is a geometric progression where the first term is 1 and the common ratio is 1.005. So generalizing this, we get AN is equal to A0 multiplied by 1.005 to the power of n minus 800 outside of 1 minus 1.005n over 1 minus 1.005. So that's the sum to n terms of the geometric progression. So A94 is equal to 60,000 multiplied by 1.005 to the power of 94 minus 800 outside of 1 minus 1.005 to the power of 94 all over 1 minus 1.005, and that equals 187.8459, and rounding that to 2 decimal places, that equals $187.85. Question 27. A cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. Once a day for 20 days, the scientist collects data. Based on the 20 data points, the scientist provides the information below. A box plot of the temperature data is shown. The mean temperature in the dataset is 0.525 degrees Celsius below the median temperature in the dataset. A total of 684 chirps was counted when collecting the 20 data points. The scientist fits a least squares regression line using the data, x, y, where x is the temperature in degrees Celsius and y is the number of chirps heard in a 15-second time interval. The equation of this line is y equals negative 10.6063 plus bx, where b is the slope of the regression line. The least squares regression line passes through the point x bar, y bar, where x bar is the sample mean of the temperature data and y bar is the sample mean of the chirp data. Calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius. Give your answer correct to the nearest whole number. The solution is based on finding the value of b in the equation of the least squares regression line, noting that this regression line passes through a particular point, x bar, y bar. So by substituting this point into the equation, we can solve for b, and then use that to calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius. But first, to find the value of x bar. The median of x is equal to 22, and that comes from point number 1, referring to the box plot of the temperature data. Now x bar is equal to 22 minus 0.525, and the second point tells us that the mean temperature in the dataset x bar is 0.525 degrees Celsius below the median temperature. So x bar is equal to 22 minus 0.525, hence x bar is equal to 21.475 degrees. Y bar, which is the mean of the chirp data, is equal to 684 divided by 20, hence y bar is equal to 34.2, and that comes from the third point in the question. Now the equation y equals negative 10.6063 plus bx passes through x bar, y bar, that's 21.475, comma, 34.2. So we're going to substitute this point into the equation and solve for b. So 34.2 is equal to negative 10.6063 plus b multiplied by 21.475, since this point lies on the line. And solving for b equals 2.0864400047. So I left that unrounded. Now when x equals 19, substituting x equals 19 into the formula, now that we know the value of b, y is equal to negative 10.6063 plus 2.0864400047 multiplied by 19. And that equals 29.036 and so on. And rounding that to the nearest whole number, that equals to 29. So the number of chirps expected in a 15-second interval at 19 degrees Celsius is 29. Question 28. In a particular country, the hourly rate of pay for adults who work is normally distributed with a mean of $25 and a standard deviation of $5. Part A. Two adults who both work are chosen at random. Find the probability that at least one of them earns between $15 and $30 per hour. The probability that at least one out of the two adults earns between $15 and $30 per hour is equal to 1 minus the probability that neither adult chosen earns between $15 and $30 per hour, and that's based on complements. First, to work out the probability that one adult chosen earns between $15 and $30 per hour. And we can use z-scores since the data is normally distributed. So the z-score for $15 is equal to 15 minus 25 divided by 5. So that's the raw score minus the mean divided by the standard deviation. That's equal to -2. And the z-score for $30 is equal to 30 minus 25 over 5, and that equals 1. Now the probability that one adult earns between $15 and $30 per hour is equal to the probability that the z-score lies between -2 and +1. And by the empirical rule, that's equal to 0.95 divided by 2 plus 0.68 divided by 2, and that equals 0.815. Now the probability that an adult chosen does not earn between $15 and $30 per hour is equal to 1 minus the probability that an adult earns between $15 and $30 an hour. So that's 1 minus 0.815, and that equals 0.185. The probability that at least one adult chosen out of the two earning between $15 and $30 per hour is equal to 1 minus the probability that neither adult chosen earns between $15 and $30 per hour. So that's 1 minus 0.185 multiplied by 0.185, or 0.185 squared, and that equals 0.965775. Part B. The number of adults who work is equal to 3 times the number of adults who do not work. One adult is chosen at random. Find the probability that the chosen adult works and earns more than $25 per hour. $25 per hour corresponds to a z-score of 0 since it's equal to the mean. Now the probability that z is greater than 0 is equal to half, since half the area under the normal curve is above the mean and the other half is below the mean. Now the probability that an adult works is equal to 3 over 4, since there are 3 times as many adults who work compared to those who do not, and that corresponds to a ratio of 3 to 1. So out of the 4 adults, 3 work, hence the probability is 3 over 4. Now the probability that an adult works and earns greater than $25 per hour is equal to the product of these two probabilities. So that's equal to half multiplied by 3 over 4, which equals 3 over 8. Question 29. The diagram shows the graph of y equals c ln x, where c is greater than 0. Part A. Show that the equation of the tangent to y equals c ln x at x equals p, where p is greater than 0, is y equals c over p multiplied by x minus c plus c ln p. The gradient of the tangent at any point on the curve is given by the first derivative dy dx. Given y equals c ln x, dy dx is equal to c over x. At x equals p, the first derivative is equal to c over p, and also the y coordinate when x equals p is c multiplied by ln p. And we get that by substituting x equals p into the equation of the curve. Now what this is saying is that the tangent passes through the point p comma c ln p, and that'll be useful a little bit later on. Now the equation of the tangent is in the form y equals mx plus c, or y equals mx plus c1 here, because this c is different to this c here. So this c here, I called it c1, refers to the y-intercept of the tangent. Now the gradient m is c over p, and that was determined previously. So we need to find the y-intercept c1. So rearranging this formula and substituting into this formula the point p comma c ln p, we get c1 is equal to y minus mx, which is equal to c ln p minus c over p multiplied by p. The p's cancel, and we get c ln p minus c. So therefore, the equation of the tangent is y equals c over p multiplied by x minus c plus c ln p as required. Part B. Find the value of c such that the tangent from part A has a gradient of 1 and passes through the origin. The gradient of the tangent is equal to 1, but the gradient of the tangent from part A is equal to c over p. Hence, c over p equals 1, and multiplying both sides by p, we get c equals p, and we'll call that equation number 1. Now the tangent also passes through the origin, which means the y-intercept is equal to 0. Hence, negative c plus c ln p equals 0. Factorising out c, we get c outside of ln p minus 1 equals 0, and we'll call that equation number 2. Now one solution is c equals 0, but we're given that c is greater than 0, hence c equals 0 is not a valid solution. So solving equation number 2 for p, so solving for this bracket equal to 0, ln p minus 1 equals 0, adding 1 to both sides, we get ln p equals 1, and raising both sides to base e, we get p equals e. But c equals p from equation number 1, hence c must equal e. Question 30. The diagram shows two parabolas, y equals 4x minus x squared and y equals ax squared, where a is greater than 0. The two parabolas intersect at the origin O and at capital A. Part A. Show that the x-coordinate of capital A is 4 over a plus 1. The x-coordinate of point capital A is found by equating y equals ax squared with y equals 4x minus x squared. So we're going to solve for x the equation ax squared equals 4x minus x squared. Moving everything over to the left-hand side, we have ax squared plus x squared minus 4x equals 0. Factorising out x, we have x outside of ax plus x minus 4 equals 0. Now one of the solutions is x equals 0, which represents the x-coordinate of the origin. The other solution is found by solving ax plus x minus 4 equals 0. Adding 4 to both sides of the equation, we have ax plus x equals 4. Factorising out x from the left-hand side, we have x outside of a plus 1 equals 4, and a is greater than 0. And dividing both sides by a plus 1, we have x is equal to 4 over a plus 1 as required. Part B. Find the value of a such that the shaded area is 16 over 3. The shaded area is the area enclosed between the two curves y equals ax squared and y equals 4x minus x squared. For the sake of explanation, let u equal 4 over a plus 1. We want to solve for a the equation, the absolute value of the integral from 0 to u of ax squared minus 4x minus x squared in brackets dx equals 16 over 3. Now the absolute values here ensure that the value of the integral on the left-hand side cannot be negative. Expanding the brackets, we get the absolute value of the integral from 0 to u of ax squared minus 4x plus x squared dx equals 16 over 3. Collecting the like terms in x squared, we have the absolute value of the integral from 0 to u of a plus 1 in brackets multiplied by x squared minus 4x dx equals 16 over 3. Integrating the left-hand side, we have the absolute value of a plus 1 over 3 in brackets multiplied by x cubed minus 2x squared from 0 to u equals 16 over 3. Now when x equals 0, the left-hand side equals 0. And when x equals u, we have a plus 1 over 3 u cubed minus 2 outside of u squared. Of course, we continue using the absolute value sign there. And that equals 16 over 3. Now substituting 4 over a plus 1 for u, so we're going to substitute out the u and substitute in 4 over a plus 1. We have the absolute value of a plus 1 over 3 in brackets multiplied by 4 over a plus 1 all cubed minus 2 outside of 4 over a plus 1 all squared equals 16 over 3. Now expanding some of these brackets, not all of them, we're going to leave the a plus 1 all squared intact. But what we can see here is we have an a plus 1 in the numerator, but we have an a plus 1 all cubed in the denominator. Now 4 cubed is equal to 64. The 3 is here, so that remains in the denominator. But we have an a plus 1 in the numerator here, but we have an a plus 1 all cubed in the denominator here. So there'll be some cancellation. So we'll end up with 64 over 3 outside of a plus 1 all squared. That's the simplification of this term here. Minus 32 over a plus 1 all squared, which is a simplification of this term here. So expanding part of the bracket here. So we're leaving the a plus 1 all squared intact here as well. And that equals 16 over 3. Now multiplying both sides by a plus 1 all squared. Now a plus 1 all squared cannot be negative. So we have the absolute value of 64 over 3 minus 32 divided by 16 over 3 equals a plus 1 all squared. So there's kind of two things happen there. We divided both sides by 16 over 3, but we multiplied both sides by a plus 1 all squared. So that is shown here in this step. Now taking the square root of both sides, we have a equals the square root of the absolute value of 64 over 3 minus 32 divided by 16 over 3, but then we minus 1, and that's taking this plus 1. So after we take the square root, this plus 1 moves over to the other side after the square root and becomes minus 1. Now what's under the square root sign there? The absolute value of 64 over 3 minus 32 divided by 16 over 3 is in fact equal to 2. So therefore, a is equal to the square root of 2 minus 1. Question 31. The population of mice on an isolated island can be modelled by the function m of t equals a sine pi over 26t plus b, where t is the time in weeks and t is greater than or equal to 0 and less than or equal to 52. The population of mice reaches a maximum of 35,000 when t equals 13 and a minimum of 5,000 when t equals 39. The graph of m of t is shown. Part A. What are the values of a and b? A represents the amplitude of the sine wave, which is the distance from the line of centre to either the peak or the trough. Now A can be found by finding the difference between the peak and the trough and dividing that by 2. So A is equal to 35,000, which is the peak, minus 5,000, which is the trough, and then dividing that by 2, that equals 15,000. Now B represents the line of centre, or the mean value of the sine wave, and that can be found by finding the average of the peak and the trough. So B is equal to 35,000 plus 5,000, and dividing that total by 2, that equals 20,000. So m of t is equal to 15,000 sine pi over 26t plus 20,000. Part B. On the same island, the population of cats can be modelled by the function c of t equals negative 80 cos pi over 26 outside of t minus 10 plus 120. Consider the graph of m of t and the graph of c of t. Find the values of t, where t is greater than or equal to 0 and less than or equal to 52, for which both populations are increasing. A function is increasing at a point if the value of the first derivative at that point is greater than 0. We want to find values of t such that m dash of t and c dash of t are both greater than 0. Consider m dash of t or dm dt, and that's equal to pi over 26 multiplied by a multiplied by cos of pi over 26 times t. This is a cosine curve that's been dilated horizontally and vertically, but we're only going to consider the horizontal dilation. Here's a rough sketch of m dash of t, which shows the dilated cosine curve. Now note that due to the dilation, one period is equal to 52 weeks, and the part of the cosine curve that's above the x-axis, which is the part that we're interested in, is between 0 and 13 and 39 and 52 weeks. So m dash of t is greater than 0 for t between 0 and 13, or t between 39 and 52. Let's consider c dash of t or dc dt. And that's equal to pi over 26 multiplied by 80 multiplied by sine of pi over 26 outside of t minus 10. This is a sine curve that's been dilated vertically and horizontally and also translated horizontally. Now, if we replace pi over 26 outside of t minus 10 with theta, we want values of theta such that sine of theta is greater than 0. And we know that sine of theta is greater than 0 for values of theta between 0 and pi. So we can solve for t if we treat this angle as an inequality. I'm going to treat this as a two-way inequality, in fact. So we want pi over 26 outside of t minus 10 to be between 0 and pi, since that's the part of the sine curve that we're interested in. Solving this two-way inequality by multiplying both sides by 26 and dividing both sides by pi, we get t minus 10 is between 0 and 26, and adding 10 to both sides, we get t is between 10 and 36. And graphing both of these inequalities, so this inequality there and this inequality there, on a number line, we look for the part of the inequality that overlaps. So we can see that there's an overlap between m dash of t and c dash of t from 10 to 13 weeks. So therefore, both populations are increasing for t between 10 and 13 weeks. Part C. Find the rate of change of the mice population when the cat population reaches a maximum. C of t is a cosine curve that's been reflected in the x-axis, with the peak occurring when the angle pi over 26 outside of t minus 10 is equal to pi radians. If you compare that with the standard cosine curve y equals cos of x, the minimum value occurs when x equals pi radians. So reflecting that cosine curve in the x-axis, what was the minimum becomes the maximum. Now, to find the point where the peak value occurs, we solve this equation for t. And solving this equation for t, we get t equals 36. So the peak value of c of t occurs when t equals 36, or at the 36th week. Now, from part B, this is to find the rate of change of the mice population. We've already found m dash of t, and we're just going to substitute 36 for t in the equation m dash of t. And that equals pi over 26 multiplied by 15,000 multiplied by cos of 36 pi over 26, making sure that your calculator is in radians. That equals negative 642.706, and so on. Now, this is a negative result, which means that the mice population is decreasing. So therefore, the mice population is decreasing at 643 mice per week, rounded to the nearest whole number.